Oxoacids of halogens. Already I said halogens forms oxoacid. The halogens mean fluorine, chlorine, bromine, iodine. Here the fluorine can only one, that is fluorine can form only one oxoacid. Other, that's mean chlorine, bromine, iodine can form several oxoacids of halogens. That is here uh, the halogens, that is most of them, they cannot be isolated in the pure state. They are stable only in aqueous solution or in the form of their salt. So oxoacid of halogens we can see here. There is halic acid first. Halic 1 acid. The halic 1 acid means the form first HOF. The name is hypochlorous acid for chlorine, hypochlorous acid for bromine, HOBr. This is hypobromous acid, and for iodine, hypoiodous acid. So this is halic 1 acid from HOF. In this case, the fluorine have +1 oxidation state. Others, the fluorine always exhibit -1 oxidation state, except the hypofluorous acid. Here only they exhibit +1 oxidation state. Then halic 3 acid. Halic 3 acid. In this is for fluoride, this bromine, sorry, oxoacids of chlorine, bromine, and iodine. The halic 3 acid, fluoride not possible. In chloride ion, that is chlorous acid, HOCl2, or sorry, HOClO or HClO2, whatever it is, you can write. This is called chlorous acid, and bromide and iodine not possible. Then halic 5 acid. The halic 5 acid in form, that is chloric acid, HClO3 or HOClO2. This is chloric acid. Similarly in bromic acid, HOBrO2. This is bromic acid. HOIO2, this is iodic acid. You can write like this, R HClO3, HBrO3, HiO3. You can write like this. Here similarly HClO2. You can write anyway. Then halic 7 acid. The halic 7 acid, this indicates the +1 oxidation state. Here this halic indicates that is chlorine +3 oxidation state. Here the +5 oxidation state, chlorine, bromine, iodine, and here +7 oxidation state for this is HClO4, perchloric acid, that is HOClO3 or HClO4. This is perchloric acid. Then perbromic acid, periodic acid. So HOBrO3 or HBrO4. Then HOIO3 or HiO4. So this is perbromic acid and this is periodic acid. Then there's some structures also we can see here. The hypochlorous acid, structure of HOCl. The HOCl like this O and the Cl. This is hypochlorous acid. Then chlorous acid. Just you have to write like this, HO and Cl. Where HOCl, 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 HOCl like this, so that you have to write this form, and the remaining you have to add that oxygen, number of oxygen. So here the HO ClO2, HOClO2. Sorry, not HOClO2, that is HOClO. So it's a form like this. Here the chlorine oxidation status 3, that's why 3 bonds. Then 5 HOClO2. HOClO2, just like you have to draw the structure like this, HOCl, then remaining was two hydrogen, 2 oxygen. So just like write like this, and here the oxidation state is 5, so that here the chlorine satisfied with the 5 bond. 4 plus 1 5, here 3, 1 plus 2 3, here 1, so that 1 chlorine atom. Then this is a chloric acid, and the perchloric acid for 7 perchloric acid is the same way you have to follow. Perchloric acid HClO4, HClO4, the same way here the hydrogen, oxygen, chlorine. Then number of oxygen is 4, here only 1 present, the remaining 3 you have to draw. So oxygen, oxygen, oxygen. Here the oxidation status was +7, so that number of bond count 4. So remaining is what? 3. So adding up double bond of each oxygen atom, you will get the structure of perchloric acid. This is the way of drawing the structures of oxoacids of halogens. Then the interhalogen compounds we will discuss. The interhalogen compound. The interhalogen compounds means what? The two different halogens react with each other. That is called interhalogen compound. They are formed interhalogen. They are assigned X dash, X dash 3, X dash 5, and X dash 7, like this. Here the X and X dash, the halogen, the X is a larger size compared to this halide. Then the X is more electropositive than that is here the electropositive is more, this is only the electropositive, and the ratio between the radii of X and the X dash is increases. See, the number of atoms per molecule also increases here. Then they form like iodine 7 fluoride, that is should have the maximum number of atoms, the ratio between the ratio of the radii between I and F, that is iodine and the fluoride ion, that is should be maximum. That is why the formula will be IF7, that is the maximum number of atoms, the IF7 having the maximum number of atoms. Then the preparations of the interhalogen compound, that is the direct combination or the action of halogen on lower interhalogen compounds, the products formed depends upon the specific condition. For example, here the chlorine react with fluorine. Yes, this means these are equal amount. The equal amount of the molecules and the temperature is 437 Kelvin to form ClF. Then chlorine in excess of fluorine, here fluorine is excess, the temperature is changes here, that is 573 Kelvin to form 2 moles of ClF3. So this is also an interhalogen compound. Then iodine react with chlorine, that is also equimolar or equal amount to form iodochloride, that is 2 moles of ICl. Then excess of chlorine, this is excess of chlorine to form 2ICl3. Then bromine react with bromine and fluorine, here this is diluted with water to form trifluorobromide, 2 moles of trifluorobromide. And similarly here excess of chlorine to form bromine react with the excess of fluorine to form BrF5. So this is the preparation method and the properties. Here the type X dash 1 type means the formula will be that is CLF. The compound is colorless gas, and the BRF, the compound is pale brown gas. This IF is a very unstable compound, and they are detected spectroscopically. They can be detected by spectroscopic studies, that is called the color. We can determine with the help of spectroscopic studies. Then the BRCl. The BRCl is a gaseous form, and the pure solid, that is in room temperature. This is in solid and room temperature. Then that's ICl. This is ruby red solid, that is alpha form. In beta form, red solid, brown red solid, and IBR, that is black color, blackened solid. So these are the physical properties of this type of compound, X-1. Then the physical properties and color of XX-3 compound, that is the type. The formula of compound is ClF3. The ClF3 is colorless gas, and the shape of the molecule, the structure is bent T shaped. Then BrF3 is yellow green liquid and bent T shaped form. Then IF3, yellow powder. This is yellow powder and the bent T shape. ICl3, that is orange solid. This is also bent T shaped form. Then the type is XX-5. The compound, the molecular formula IF5, colorless gas, but the solid below 77 Kelvin. The structure will be square pyramidal, and the BrF5, colorless liquid. This structure also square pyramidal, and ClF5, colorless liquid, and this is also square pyramidal. All these compounds having a square pyramidal structure. Then compound XX-7. Here the only one possible compound, that is IF7, colorless gas and pentagonal bipyramidal is the structure. So this is the properties of the interhalogen compounds and the types of the interhalogen compound. These are all covalent molecules, and the diamagnetic in nature, that is the magnetic behavior, and they are volatile solid or liquid at 298 Kelvin temperature, except ClF. This one. And this is a gaseous molecule, and their physical properties are intermediate between those of the constant halogen, except their melting point and the boiling point are a little higher than the expected. So their chemical reaction can be compared with the individual halogens. The interhalogen compounds are more reactive than halogen, that is except fluorine case. This is because the X bond is interhalogen is weaker than X bond, that is the halogens except that fluorine bond. So, this undergoes hydrolysis, giving the halide ion derived from the smaller halogen and a hypohalide halide like this, perhalide from the larger halogen like this. You can see XX react with water to form HX and HOX. So the molecular structures are very that is we can see with the help of that is VSEPR theory. Based on the VSEPR theory, the compounds have the bent T shape. Compounds are that is XX-5 is X-3. This is bent T shape, and this is a square pyramidal, and IF7 is a pentagonal bipyramidal structure. So this is the properties of the interhalogen compound and the user. The uses it is used as an interhalogen compound, used as a non-aqueous solvent. It is used as a fluorinating agents. The production of uranium, hexafluorouranium, and like this, the uses is uranium solid react with ClF3 liquid to form hexafluorouranium gas, and 3 ClF gas is formed. So this is the user. Next is the group 18 element.